This video is all about the chain rule. Now, the chain rule, just like if you have a function, let's say for instance, you have y to be equal to, let's say v into u, okay, let me say u into v into x of x. Now, the derivative of this, let's say the derivative of y with respect to x will be the derivative of y with respect to this y, this u, times the derivative of this y with respect to this v, times the derivative of this x with respect to this v, the derivative of this v with respect to x, the derivative of y with respect to u, that is from here, the derivative of y with respect to u, the derivative of u with respect to v, the derivative of v with respect to x, and then the last one, the derivative of x with respect to this x. So this is a chain rule. That is how to work it out. So that is it. So now let's say we have a problem. Let's say for instance we have a problem. This is a chain rule. This is a formula for chain rule. Now let's say we have an issue now. Let's say we have a problem. We say we want you to get the derivative of bracket open 2x plus 5 raised to power 5. Now the derivative of this is, now this is a function. This one, the whole of this is also a function, which is this. So differentiating this whole function, differentiating this whole with respect to this function, you will now have, you bring the exponential out here, you say 2 into 2x plus 5, then you subtract 1 from this exponential, which is 4, times the derivative of this one inside here with respect to x. So that will be 2. So 2 times 5, you will now have 10 bracket open 2x plus 5 bracket close 4. So this is it. So, or if you want to make it simpler, in simple form, with the whole of the way this thing is, you say let u be equal to 2x plus 5. This is a function which shows that u is a function of x, which is 2x plus 5. Then let's say y is now a function of u to the power of 5. Now the derivative of y with respect to u will just be 5 u. Now you subtract 1 from the power, you have 4. So this is the same thing. If you substitute u here, now it's the same thing with this, which is 5 bracket open 2x plus 5 raised to power 4. Now the derivative of u with respect to x will now be 2. So if you now use the chain rule, so the derivative of y with respect to x will be derivative of y with respect to u function times the derivative of u with respect to x. So now, which is 5 into 2x plus 5 raised to power 4 times 2, which is 10 into 2x plus 5 raised to power 4. So that is it. So now let's look at the second question. The second question, let's say you have x, you have 2x to cube minus 5 raised to power 3. So now we're looking for the derivative of this. So now to do the derivative of that, this is a function, this one inside here is a function. So we differentiate this whole thing, this whole function with respect to this function that is inside this parenthesis, this bracket. So now you now have 3 into, 2x cubed minus 5. Keeping this one the same. Now keeping the one inside the bracket the same because you are differentiating with respect to the function inside the bracket. So now you now subtract the exponential here, then times, you now do the derivative of this with respect to x. So now that will be 2 times this 3x to the power 2. So this will give you 6. 6 times 3, this is 18x squared into 2x cubed minus 5 raised to power 2. So this is the answer. Now let's do another one. You have the square root of 4x minus 3. So the derivative of the square root of 4 minus 3. So this will give you, now let's rewrite this in the form of exponential. So you have the derivative of this function. This function can be written as 4x minus 3 all to the power half, raised to the power half. Now if you now do the derivative of this function, now you will differentiate this with respect to this function inside here. So that means this function will remain the same. So you have the exponential, use the exponential to multiply it according to the power rule into 4x minus 3, then 1 over 2 minus 1 times the derivative of this with respect to x, you have 4. So this will now be 4 times 1 over 2 is 2. This is 4x minus 3 raised to power 1 over half minus 1 is minus half. So this is the final answer, and you can rewrite it to be 2 divided by the square root of 4x minus 3. So this is the final answer. Now let's look at another one. You have the derivative of dx into 1 all over x squared plus 3 all to 4. So this will be equal to, so now this can be written in another form to be the derivative of this x squared plus 3 all to the power minus 4. So when you do the derivative of this, now you differentiate it with respect to this function. Now you will now bring the exponential here. You have 4 into this. Since you are differentiating with respect to this function inside here, the function inside will remain the same, plus 3. Then here will be minus 4 minus 1, which is minus 5, times the derivative of this inside function with respect to x, which is 2x. So this 2x times this, you have minus 8x times x squared plus 2 plus 3 divided by minus 5. So this will give you minus 8x all over x squared plus 3 raised to power 5. Now we now have the next one, which is the derivative of this with respect to x, which is x to the power square minus x plus 7 all divided all to the power 2. So all to the power 2. So the derivative of this is You differentiate this with respect to this function that is inside. So you now have 2 into x square minus x plus 7 over 2 minus 1. This one inside will remain the same. Then you differentiate with respect to the function inside here. You differentiate with respect to x, this function inside. So differentiating to x square, you have 2x minus, differentiating this to minus 1, this is 0. So this is our final answer. So be 2 into 2x minus 1 into x square minus x plus 7. So this is the final answer. Now the next question is, we give you question like this. You have 3 divided by the cube root of x square minus 4. So this is the derivative of this. So this is the same thing as the derivative of this, which is 3 times x square minus 4 is raised to the power minus 1 over 3. So this is this expression. We write it in this simpler form. Now we can solve it out. Now this constant, we can bring it out. So it's not a variable, it's a constant, so bring it out. We now have x squared minus 4 raised to power 1 over 3. So the derivative of this, you have 3 times the derivative of this. We write the whole of this function with respect to this function inside. You have minus 1 over 3 times x to the power 2 minus 4 raised to the power minus 1 over 3 minus 1. Now this will remain the same, then times the derivative of this function inside here with respect to x, which is 2x. Now we now have this will cancel out, we have minus left. So now this minus 1 times 2x, we have minus 2x divided by x square minus 4 raised to power. So this will be raised to power minus 4 over 3. Sorry, raised to power plus 4 over 3, because it's under here now, but here now it will be minus 4 over 3. So coming down here the way it is, it will be plus 4 over 3. So you have minus 2x divided by the cube root of x squared minus 4 all to the power 4. So this is the final answer. So now let's say you have another problem, which is, we say do the derivative of this. So we're still using chain rule. This tan, you have tan, let's say 2x squared plus 5. Now you have a function and you have another function. So the derivative of this will now be, you're differentiating this with respect to this function. So you have x squared. This will remain the same, which is 2x squared plus 5. Then times the derivative of this function with respect to x, you now have 4x. So the final answer will be 4x sec squared 2x squared plus 5. So this is the final answer. So now look at this, another problem that looks similar to that. You have the derivative of sine 3x squared plus 5x plus 4. So the derivative of this now, we say you derive you do the derivative of the whole of this function with respect to sine. So you have cos. This one will remain the same. You have 3x squared plus 5x plus 4. So you're differentiating this with respect to this function inside here, and then times the derivative of this function with respect to x, which is 6x plus 5. So this will give you 6x plus 5 cos 3x squared plus 5x plus 4. This is the final answer. And the next is, now let's say find the derivative of cosec. Let's say cosec 4x cubed plus 2x squared plus 4. Now for us to do this, you differentiate this with respect to this function. So differentiating this with respect to this function, you have minus cosec x cosec this function, which will remain the same, times cot this same function, which is 4x 3 plus 2x 2 plus 4, times the derivative of this function with respect to x. So now we differentiate this cosec with respect to this function, you have this. Then differentiating this function with respect to x, you have 12x squared plus 4x. So this will give you minus 12x squared plus 4x times cosec 4x cubed plus 2x squared plus 4 cot 4x cubed plus 2x squared plus 4. So this is the final answer. But let me show you how the derivative of cosec, let's say u function with respect to x is equal to this. Now assuming this cosec, this cosec is the same thing as saying 1 all over the derivative of 1 all over sine u. Okay, this is u, sorry, let's make this u. Now, and this is same thing as the derivative of sine u raised to the power minus 1. Now you now have, if you differentiate this, you differentiate the whole of this function with respect to this sine u, you have minus 1 into sine u raised to the power minus 2 times differentiating this sine u with respect to u, you have cos u. Now this will give you minus cos u divided by sine square u. So this is the same thing as cosec u cot u. So that is why we have cosec u cot u here. Oh, also assuming this is u, now you're differentiating this whole thing with respect to this function here. That is why this is not changed. It did not change here. So now let's go to the next question. Let's go to the next one. Let's say you have the derivative of tan. You have the derivative of tan x raised to the power 4 plus 5x cubed. Now, the derivative of this, you differentiate tan with respect to this whole function inside here. You now have sec square. Now, this function remains the same. Now, times the derivative of this function with respect to x. So you have 4x to the power 3 plus 15x to the power 2. So this will give you 4x to the power 3 plus 15x to the power 2 sec square 4x to the power 4 minus n plus 5x to the power 3. So this is the final answer. This is the final answer. A more simpler way to do it that you understand. Let's say you have tan. You ask to get the derivative of tan 4. Now, assuming this is your, let's say this is y and this is your u. This u is a u function. Is u of x is 4 to the power 4 plus 5x to the power 3. So now that means your y is equal to, your y function of u is equal to tan u. Now differentiating the y with respect to x will be differentiating the y with respect to u, which is this, times differentiating u with respect to x. When this cancels, you have the same thing. Now differentiating u, differentiating y with respect to u, that is differentiating y with respect to this function, you have sec square u times, see the u remains the same, now times differentiating this with respect to x, which is this. So you now have 4x cubed plus 15x squared. 15x squared. So putting u here, this is u here, you see, you come to the same answer. You come to the same result. So that is it. So that is a simpler way to get it understood. Now the next question that looks more like that. Now let's say the derivative of cosec 4x cubed plus 2x squared plus 4. So the derivative of this is, okay, I've done this. Okay. Let's just touch it now. Cosec. The derivative of this cosec of the whole function with respect to this. The derivative of the whole function with respect to this function inside this bracket will now be cosec of this function, cosec of this function, cot of that same function times the derivative of this one with respect to x. So it's just like saying, okay, so which is 12x to the power 2 plus 4x. Okay, I've done this before. This should be minus here. So you have minus 12x squared plus 4x cosec 4x cubed plus 2x squared plus 4 cos 4x cubed plus 2x squared plus 4. So this is the final answer. Now let's look at, you have this particular kind of problem, ln x cubed all to the power 5. Now what we're going to do now is there are three functions. Now you differentiate the whole with respect to this function inside, with respect to this whole function inside. So now you have this exponential, bring it here, times ln x cubed. Leave this the same because you're differentiating with respect to this function here inside. So you subtract 1 from this 5, you have 4. Then times, now you will now do the derivative of this with respect to the whole of this function. With respect to the whole of this function, you now have 1 all over x3, that is a function. Then times, now you need to do the derivative of this function inside here with respect to x. So now you have 3x squared over 1. So that is it. So now you have 5 times 1 times this will give you 15x squared all over x cubed times ln x3 all to the power of 4. Now if you cancel this, it remains 1 here. You now have 15. You now have 15 ln x to the power 3 all to the power 4 divided by 8. So this is the final answer for this. The final answer for this. Now let's say you have a problem that looks like this. You are asked to find the derivative of cos cube into tan into sine x4 so we can rewrite this in this other form. Now bringing these 3 out, you have cos, no, you have this tan, you have sine, you have x4 with these brackets. This is one, this one, this one, this with the one, then this whole one, square, cube it. Now to do this, you differentiate this. You say 3 into cos, that is into, now you're differentiating with respect to this, the whole of this inside here. So the whole of this inside here will remain the same. You're differentiating with respect to this function. So the function will remain the same. So you have cos, then tan, then sine x4. Now, then this will be 2. Then you now differentiate this with respect to the whole of this one inside here. So the whole of this one inside here will remain the same. It's just only this one you will differentiate. So now you have sine of this tan sine x4. Now having done this, we now need to multiply again, differentiate this with respect to this one inside here. So you have times sec square sine x4. Now, so you have this. So now differentiating this one inside here with respect to differentiating with this one inside here with respect to this x to the power 4. You now have cos. Okay, this is supposed to be minus, sorry, cos be minus. You now have differentiating there, you have cos x to the power 4. So this will remain the same because differentiating with respect to this function x to the power 4. So now we are now differentiating this x to the power 4 with respect to x. You have 4x cubed. So the whole now be, you have 3 into cos into tan into sine into x power 4 square. We should minus here, minus sine tan sine x1, then this sec times sec square sine x1 times cos x4 times 4s cubed. So that is the final answer for this. Now we can just stop here. We can bring this to this place. So let me just clean it. You have 4x cubed. So you bring 4x cubed here. Let me clean this. You bring 4x cubed here to be 12x cubed. Because 3 times 4 is 12. So it will be like this. So that is it. So that is the final answer. Thank you for watching. Have a nice day. Now let's end it here.